All right, I had someone ask me to explain outside of the videos that you guys watched this question F from, I believe this is mock exam 2. This is question 1F. It tells us the function g satisfies g of x equals x plus 5 cosine 1/5 pi x over 3 minus the square root of f of x for x does not equal 5. It is known that the limit as x approaches 5 of g of x can be evaluated using L'Hopital's rule. Remember, L'Hopital's rule says when we're evaluating a limit, it's the limit is the derivative of the top over the derivative of the bottom to find f of 5 and f prime of 5. Show all the work that leads to your answer. All right, so I wrote this function out up here on my paper here, but I do want to point out that they said right here the limit as x approaches 5 of g of x. Okay, we know that from our stem, if I flip back on my pages here, that f is it f I want to talk about? Give me a second. Excuse me, g. They're all the same, but g is twice differentiable. Remember, differentiability implies that it is continuous. So if that limit is differentiable, this one right here, if g is differentiable, that means it is continuous. And if it's continuous, if you look back in your foldable here, we have something on continuity right here. Three things that make it continuous is the limit exists. We know that's true. F is defined. The point is defined because we are told that back in our stem that g of 5 equals 1. That's right here. The point is defined, and that the limit equals the point, which means this. The limit as x approaches 5 of g of x equals g of 5, which equals 1. Okay, we know that to be true. All right, so to do the first part, we're going to find f of 5. This is just my little notation to find f of 5 here. Okay, to find f of 5, we can take the limit, and we're going to go ahead and take the limit of the numerator, and we're going to take the limit of the denominator. Okay, so here's what we know. The limit as x approaches 5 of x plus 5 cosine 1/5 pi x is equal to, I'm just going to plug my 5 in. So that's going to give me 5 plus 5, and then we're going to plug a 5 into this x. 5 times 1/5 is 1, so that's just going to be the cosine of pi. The cosine of pi is -1, times that 5 is -5. 5 plus -5 is 0. So we know that that numerator is 0, which means using L'Hopital's rule, or knowing we're allowed to use L'Hopital's rule, we know that we have to get 0 over 0. If we got 0 over some other number, then it wouldn't be L'Hopital's rule. We would just have 0 as our answer. So we know that the limit as x approaches 5 of our denominator must also equal 0. Okay, I believe, I was just rewatching the video earlier, they said this was -1, and they said 5 plus -1 is 0. He meant to say -5. This is -1 times that 5. All right, so let's do that denominator now. We know the limit as x approaches 5 of 3 minus the square root of f of x equals 0. So we're going to plug our 5 in, and we get 3 minus the square root of f of 5 equals 0. The reason why we say 0 is because we know that the numerator was 0, so the denominator has to be 0. And now just using algebra, 3 equals the square root of f of 5. This is more of square both sides if you want, but you square both sides, you get 9. Or you just know that that has to be 9, so that we get the square root of 9 is 3. Okay, so that's how we got f of 5. F of 5 is 9. Okay, that's going to come, we're probably going to need that value somewhere down the road in our second part. We're finding now f prime of 5. Notice that we do not have an f prime in our equation, but they told us to use L'Hopital's rule, and L'Hopital's rule is going to allow us to take the derivative of the top and the derivative of the bottom. Okay, so let's go ahead and do that. The limit as x approaches 5, and we're going to take the derivative of the top. The derivative of x is 1. The derivative of cosine is going to be negative sine, so we're going to have negative 5. I'm going to leave a space because I got a chain rule here because there's going to be a chain inside here. Sine 1/5 pi x. Now the chain rule, what is the derivative of 1/5 pi x? That's 1/5 pi. So I got to put that in front here. And then over the bottom, the derivative of the bottom. The derivative of 3 is 0 minus the derivative of the square root function is 1 over 2 times the square root of the function. But since that's not an x, that's an f of x, we have a chain rule, and the derivative of f of x is f prime of x. And now we have that in our, that f prime that we need to solve for in our equation, okay? And this now goes back to this right here. We know that this limit as x approaches 5 of g of x is equal to 1. So we're just going to solve this equation by plugging our 5 in. So 1 minus 5 times 1/5 is just 1 pi sine. And now we're going to plug our 5 into here and we get pi. Over, plugging a 5 into here is negative 1 over 2. We know f of x is not f of 5, I'm sorry. F of 5 is 9. The square root of 9 is 3. And then times f prime of 5 equals 1. And we're just going to solve this now. What's the sign of pi? That's 0. So we're left with 1 in our numerator over here. This whole thing becomes 0. So 1 minus 0 is 1. Over, this is negative 1/6 f prime of 5 equals 1. Cross multiply and get 1 is equal to negative 1/6 f prime of 5. And multiply both sides by negative 6 to get rid of this negative 1/6 over here. F prime of 5 is equal to negative 6. Multiplied both sides by 6 to get rid of that negative 1/6 there. Okay, hopefully that helped you out a little bit better. The explanation there, I know they did have one little small verbal error in there if you got lost in this. It was in this part right here. But hopefully that did a little better for you. We're getting pretty close. Keep working if you're watching this, and I know you're going to do well. Good luck to you.